Hey everybody, Mr. Judson here. So we talked about finding asymptotes, vertical asymptotes, horizontal asymptotes, how to find zeros, kind of briefly mentioned a hole in the graph. We'll talk about that today. And so today what we want to do is we want to be able to graph these rational functions using that information. All right? So every single problem we do, we're always going to start by factoring the numerator and denominator. So we want to get used to that, okay? So if I factor this, I've got x plus 1 times x minus 1 in the numerator, right? Difference of two squares. This would be x times x, this would be 1 times 1. Conjugates is what we call this. When one's positive and one's negative, that causes that middle term to disappear. For the denominator, I've got x times x. And I got 5 times 1, and I want to make sure I get a positive 4. So that's a positive 5 times a negative 1. If I FOIL this, I get x squared. Then negative x plus 5x, that's 4x. 5 times negative 1, we get a negative 5. And right away, I see that two of these factors cancel. Okay? That's what a hole in the graph looks like right there. I don't know how that happened, but funny that it happened on this. The moment you cancel two factors from our original function, that means that there's going to be a hole at x equals whatever makes this factor equal 0. All right? So if I plug in a 1, I would get 0 there. So at x equals 1, there's going to be a hole in the graph. And that's what a hole looks like. But what we do is let's say our equation does something like this. We put an open circle there. That represents the hole in the graph. And it's going to be at 1 comma something. We're not sure what yet. Okay? But we just want to keep track of that so that when I actually draw the picture of the graph, I make sure I get that in there. So what that says to me is when I graph this function, it really looks like this function right here. They look the same except for the hole in the graph. The hole is caused by the original function, which if I plug in a 1, I'm going to get 0 in the denominator, and that's undefined. So we can't have a graph there. Okay? All right, so now I want to find my asymptotes. So let's see. Vertical asymptote. There's going to be a vertical asymptote at whatever makes this denominator equal 0. So at x equals negative 5. Now, I just want to make sure that this is clear to us because I was watching yesterday's video and I realized I said to you guys, denominators can't equal 0, and then the next thing I do is I write down x equals some number that makes it equal 0. Okay? Well, what I'm doing is I'm saying this is where that vertical asymptote is. When we draw that vertical asymptote with a dotted line, that means that's a spot that the graph can never touch. I can never go through a vertical asymptote, okay? We'll never touch it. And so that's our undefined part, right? That's what we mean when we put that in there, right? So we know that x cannot equal negative 5 because that's why we have a vertical asymptote there, all right? Let's see, zeros, they only happen when the numerator equals 0. So our 0 is at x equals negative 1. And then if I look at my exponents here, they're both the same. So I need to look at the leading coefficients. 1 divided by 1, that's 1. That's where my horizontal asymptote is. Oops, y equals 1. All right, so now I need to put this stuff onto a graph. So if I go ahead and get a picture here of a grid, there it is. Also, remember this, you have to draw the asymptotes in the graph, and they have to be dotted lines. In chapter 1, when we did our rational function, and we were doing the center of the asymptotes, remember the negative c over b, comma, d? A lot of people were putting the asymptotes in as solid lines or not drawing them at all. They need to be drawn and they need to be dotted lines. Okay? All right, so I'm going to get a dotted line here. I'm going to put a vertical asymptote at -5. X equals -5. That means I'm going through the x-axis at -5. And a horizontal asymptote, it goes through the y-axis at 1. So there's the line y equals 1. And I probably want to stretch it out just a little bit farther so that, whoops. So I've got some room to draw my graph out here. Okay. Now, the thing that I want to remember here is that when I draw the graph needs to get close to these asymptotes without touching. All right? Now, I know that there's a 0 at -1, so I know I have to hit this point. All right? And I also know that there's going to be a y-intercept. If I plug in zeros to this original function, I'm going to get a -5 or -1 over -5, and so there's a y-intercept at a positive 1/5, right about there. I think that just told me a lot about this graph. I think I'm going to have a curve that goes right through like this. It's got to go through those 2 points, right? And it's not going to curve and go back down because that would be another 0 here, and there's only one 0. That means that's the only place we can touch the x-axis. So I think this is the first part of this graph. There can't be anything up here because if there is, it doesn't pass the vertical line test, right? So the only other question is, I know there's got to be something out here. Is it going to be up in this area or is it going to be down here? It can't be down here because if it is, when I get close to this asymptote, I'm going to cross the x-axis again. That means there's another 0, but I know there's not, right? So I know the graph has to be up here. Now, remember, we can make it's actually going to say this in our assignment today. It's going to say plot a sufficient number of points so that you know what the graph looks like. Okay? I already know what it looks like. But, you know, if I want to make sure I'm getting this in about the right spot, well, then maybe I should make an XY table and just plug a number in and check. So let's see, this is at -5, that's -6. Let's just go -7. I'm going to plug a -7 in. And I'm not going to plug it into this equation. I'm going to plug it into the one where I had canceled the x minus 1s. So if I put a -7 in there, I get -6 over -2, which is 3. So at -7, I'm up here at 1, 2, 3, that point right there. And so now I can just go ahead and draw this curve so that I know what it looks like. Now, the only other thing I got to make sure I go back and check is we know there's a hole in the graph and it's at 1 comma something. I'm not going to plug in a 1 here because what I'll get is 0 over 0 because of that factor. I'm going to plug it in here to see what I get. So at 1, if I plug in a 1 here, I get 2. If I plug in a 1 here, I get 6. So 2/6 or 1/3. Now, you could have just said, well, I can see where the point's at right there, so let's just go ahead and put a hole in the graph. So what I need to do is I need to go back and erase this at x equals 1. So I'm going to try and just get a little bit of it there. There we go. And then I'm going to put an open circle right there, which means there's a hole at that point. Okay. Now, when you really graph it, that's what a hole in the graph looks like. Let's punch this equation into our graphing calculator. Okay? Clear that off. I'll go to y equals, and I got to put each of these in parentheses. Right? Anytime you graph something like this, you got to put your numerator and denominator into parentheses. So in parentheses, I've got x squared minus 1, close parenthesis, and then divide that by, in parentheses, x squared plus 4x minus 5. And so I'll just go zoom option 4. Probably not going to see the whole thing, but I'll at least see the hole in the graph. See it right there? There's just one empty spot. If I hit the trace button, and I'm tracing along here, I'm at 0.1, 0.2, 0.3, 4, 5, 6, 7, 0.8, 0.9, I'm getting really close to the hole in the graph. Watch what happens when this equals 1 right here. See how my y value disappeared? That means there is no point at x equals 1. That's our hole in the graph. And if I arrow to the right one more, well then the cursor pops up again, and now I'm past that hole. I'm back on the graph again. Okay? So I can see this curve. I don't see this part right here. So if I wanted to see that, I would go zoom option 6, and now I see it there. Okay, now there's a couple weird things that happen with my graph. One is, it's trying to connect the point up here to the point down here, and so that's why you see this line. It actually shows me where an asymptote should be. All right? And then the other thing that's a little bit different is you can't see the hole in the graph because now all of a sudden the pixels have changed to fit the window, and I don't have a pixel that's exactly at x equals 1. See, watch. If I hit trace and I go across, there's 0.468, oops, I went past 1. If I go backwards, 0.85. See, I'm missing the point 1 comma something. But if I want to, I can punch in a 1 and hit enter, and now I see the y value has disappeared, but I still can't see where that hole is. The only time you see the hole in the graph is when you do zoom option 4. That's why I use that so often. It shows the true picture. All right, so that's it. We've done what we're supposed to do. We've graphed this function just by finding the asymptotes and the zeros and then kind of thinking our way through the rest of it. We did find one additional point. I don't think we needed it, but we did it just to make sure. All right, let's try another one. All right, so let's find the zeros, find the vertical asymptotes, find the horizontal asymptote, and then see if you can draw a sketch of what you think this graph would look like. Okay, guys, go ahead and try it. All right, so we know we have to factor first, so let's do that. In the denominator, right away I see difference of 2 squares, so I know that's x plus 3, x minus 3. In the numerator, this has to be x times x. This has to be, let's see, two numbers you multiply to get 8 and subtract to get a negative 2. It's got to be 4 and 2. But to get a negative 2 in the middle, I want positive 2 minus 4. So we'll double check. We get x squared. My outer product is a negative 4x plus 2x on the inside. Those add up to this. 2 times negative 4, that's a negative 8. Okay. So this time nothing cancels out, so there are no holes in the graph. So we can just go ahead and draw our curve and not worry about that. I'm going to have zeros at x equals, remember the only way a fraction equals 0 is if the numerator does. So at negative 2 and positive 4. I'm going to have vertical asymptotes wherever the denominator equals 0. So vertical asymptote at x equals plus or minus 3. And if I go back and look at this, I've got a horizontal asymptote at 1 over 1, which is 1 again. So horizontal asymptote at y equals 1. So now I'll go ahead and draw that stuff into a graph. So I'll do the asymptotes first. I've got a vertical asymptote at x equals 3 or negative 3, and a horizontal asymptote at y equals 1. And my zeros are at negative 2 and 4. So let's see, there's going to be a 0 right here at negative 2, and there's going to be one at positive 4. So I think part of this graph I'm okay with. Now, by the way, just to make sure you guys get this, let me take this horizontal asymptote out of here for just a second. What vertical asymptotes do is they divide your graphing region up into 3 sections. There's 1, 2, 3. Okay? When I graph this function, I need to have something in each of those 3 sections. The question is just where. Okay? So when I put my horizontal asymptote back in here, what that says to me is if I got to have something in this section, it's either got to go here or here. And I think we already know the answer to that question. Just think to yourself real quick, where is it? Above or below? If you said below, then what you're saying is there's another 0 out here. But there isn't. If there was, I'd have a red dot on the x-axis. There's no zeros out here. It can't go there. It's got to go up here. So I already know that part of this graph looks like this. Now, is it exactly in the right spot? Probably not. Do I care? No, no. I'm just acknowledging that there's something in this area. Okay? There's also got to be something in this area, right here, right? It's either up here or it's down here. Well, we should know, because there's a 0 right there. So this graph has to go through that point, and then it's going to look like that. Okay? Now, occasionally there's something that happens that we really have no way of knowing right now. You might remember this yesterday. I told you it is possible for a graph to cross a horizontal asymptote. So I've seen equations do this. Let me take this piece back out. I've seen equations go through like this and then come back down and get close to this horizontal asymptote without touching. We have no way of knowing that without doing some calculus, okay? So if you ever check a graph on your calculator and you go, oh, that's weird, it looks like it went above the asymptote and then got close, well, we just didn't know. I suppose what we could do is we could plot a point that would tell us whether or not that's happened. Let's just go out here to 6. If I want to plug 6 back into this function and see what I get, now, me personally, I think it's easier to plug it into this. If you put a 6 in here, you've got 8 times 2, right? 6 plus 2 is 8, 6 minus 4 is 2. So 8 times 2, that's 16. If I put an 8 here, or 6 here, I've got 9 and 3. So that'd be 27. Ah, I just answered my question. See, that's a positive number, so we're above the x-axis, but it's less than 1, which means I'm not going above the asymptote like this. Right? Now, if you didn't do any of this, let me just back up. Get rid of all this. Oops, no, stay there. If you just looked at this and said, no, I have to hit this, and I'm going to do this, and if that was wrong, I'm not going to mark that wrong on a test. I'd be okay with it. You got close to the asymptotes, you hit the 0, we're doing what we're supposed to do. Now the big question here is, what's happening between these 2 vertical asymptotes? And there's a lot of different things that can happen. You can have a graph go like this, getting close to the 2 asymptotes. You can have a graph that goes like this and comes back down. It's possible the graph could go through here, not go above, and then come back down. Or it's possible that the graph could come down and bounce and go back up, if this had a multiplicity of that's even. There's a lot of different things that can happen. But again, I want you to realize it's okay to touch a horizontal asymptote, never a vertical one. Never, 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 okay? Because denominators never, never, ever get to equal 0. Okay, but you can touch a horizontal one. It's just that as you go off to infinity and negative infinity, this is where we get close without touching. Okay? So I think we know what happens here. When I look at this, there's no more zeros, so it's not going to go up and come back down. There isn't a multiplicity of 2, so it's not bouncing. It's either got to go like this, or it's got to go like this. And I think my y-intercept is going to tell me which one. Right? If I plug in x equals 0, so my y-intercept is going to be 0, comma. If I plug in zeros here, I get 0, 0, 0. I get negative 8 divided by negative 9. That's a positive 8/9. I've got to hit that point. 8/9 is just a little bit less than 1, so right about here. I know what happens now. It's not going to go like this. I missed the y-intercept. It's not going to go like this because I just added an extra 0. Right? The only thing this could do is go like this. And there's what that graph looks like. So now, of course, I want to double check this, and you guys should always double check. Don't ever just write down an answer and move on to the next problem and go, yeah, I'm sure I got it right, or I hope I got it right, or I don't really care if I got it right. No, check. Let's make sure we're getting it right. All right? So let's graph this. We'll go to y equals, we'll clear out the old graph. Still have to put it inside parentheses. So in parentheses, I've got x squared minus 2x minus 8. So what happened here? Yeah, I think my computer froze. This program, for some reason, keeps on freezing on me, the one that I'm writing on here, and it messes everything else up. So let me see if I can fix it. All right, sorry about that. 30 minutes later, I finally get my TV to work again. Oh my gosh. So I was graphing this to see if it matches up with what we have there. So I've already got the equation punched in. I'm going to go zoom option 6. And so there's what I get. You know, again, it's trying to connect the upper part to the lower part. So really that's where there's an asymptote. Same thing here. But this curve is that one right there. This piece is the middle section. And this curve right here is that piece. And so it looks to me like I got things right. My window here goes really from -6 to +6. So if I want to change it, I might get a little better of a picture. It's pretty close to the same thing. All right, let's try another one. All right, so this time we got f of x equals x squared plus 3x over x squared plus x minus 6. So I want you guys to go ahead and graph this rational function. Same way we did the last one. All right, so we'll start by factoring. So in the numerator, I can factor an x out of each of those. And in the denominator, x times x, two numbers I multiply to get 6 and subtract to get 1. Sounds like 3 and 2. So +3, -2. So that'll give me my x squared. I'll get -2x plus 3x. That adds up to this. And 3 times -2, that's a -6. So 2 factors cancel. That means there's a hole in the graph, right? So we're going to have a hole at -3, comma something. We're not sure yet. And now what I'm going to do is I'm going to say f of x equals x over x minus 2. Because this graph looks exactly like this, except this one has the hole, this one doesn't. Right? And we're trying to graph this, so I got to make sure I show the hole in the graph. Alright, so now I could say that my zeros are at x equals 0. I've got a vertical asymptote at x equals 2. And they're x squared over x squared again. 1 over 1, that's 1. So we've got a horizontal asymptote at y equals 1. So I want to put this stuff into a graph, and then we'll see what this looks like. All right, so let's see. I see a vertical asymptote at 2. There we go. I've got a horizontal asymptote at y equals 1. It's not always going to be there. Even though we just have 3 graphs in a row where it is, it's not always there. Okay? Make sure we're always thinking. And then I've got a 0 at x equals 0, right there. I think I know what this graph looks like. I think there's going to be one curve that goes like this, and there's going to be one curve up here. I can't create more zeros or x-intercepts, so it's got to be up here. Okay? So let's see. I just want to do this real quick. I'm going to make an xy table, plot a sufficient number of points. I want to know what that y value is. So when I plug in a -3, I get -3 over -5, which a negative divided by a negative is positive, so that's 3/5. So there's going to be a hole in the graph at -3, 3/5. And so when I draw the graph, I'm going to go like this, and then like that. Try not to touch the asymptote. I don't care if the arrows do, but the curve shouldn't. And then I want to have another curve up here. There it is. And now just for my own confidence, I would want to punch this into my graphing calculator just to check. So I got to go back to my original function. So we'll clear this. In parentheses, I've got x squared plus 3x. And then divide that by, in parentheses, x squared plus x minus 6. And then we'll hit graph. I think if I go zoom option 4, I should be able to see everything. Yeah, so there's what it looks like. Looks like there's an asymptote right there at 2, one right here at 1. There's my hole in the graph at -3. I can just barely see a gap there. So yeah, I think I did that one right. All right, you guys, that's what we have for today. Just trying to produce graphs of rational functions by paying attention to some things that we know. Finding zeros, vertical asymptotes happen when the denominator equals 0, okay, because that's not supposed to happen. And also the idea of horizontal asymptotes. There's a lot of things that we've worked on to kind of lead up to this point, and you can start to see how different pieces of what we've learned have come in and applied to this. All right, so let me get you guys a homework assignment. All right, so here it is. This is the end of week 13. This is our Thursday, Friday segment. We're doing page 194, 33, 34, 37, 39, and 41. These take a little longer, so we're not going to have as many problems to do, but important ideas. We want to make sure that we get all of this stuff, all right? How to find asymptotes, how to find zeros, how to find a hole in the graph, how to get all that stuff drawn into a picture. All right, guys, hey, I just really need people to email me and let me know what day you're taking the test. We're right about half of the students so far in pre-calc. That's a lot of people that are still left. I need to know. Please, I'm trying to be organized because you guys know I've got my surgery next week. I need to have this stuff all done before then. I can't be calling people Wednesday night or emailing you and saying, hey, when are you taking the test? I need for you guys to let me know. All right? And hey, I'm not going to send the test if you don't tell me. So you want to wait till after break to take it and do the retake? That's not very smart. That's 2 weeks to forget all this stuff. You'd rather take it when you have it fresh in your mind. So please, let's get that taken care of. All right? Okay, that's all I got for you guys. So have a good weekend. Stay safe. We'll see you on Monday or Tuesday. All right, bye.